Hello everybody and welcome to this Unreal Engine 4 tutorial, and in this tutorial we will be creating a simple first person shooter game like you have seen many games like Apex Legend, Counter Strike or PUBG and Fortnite of course, and we will be making this from scratch and not using the template that Epic Games provide us. So we will be creating an empty project with C++ and we will build upon that. We will be using both blueprints and C++, but mainly C++. And I'm not going to point out every little thing in the engine, what they do and what they not, but eventually when we apply them in the game, you will learn what they do. So uh, I, I have this new project window in front of me. You can just whenever you open the Unreal Engine for the first time, this will going to show you, or if you don't know how to do that, you can go to file and create new project like this. We are not doing anything film television or so, selecting game next, and this is the template first person shooter which Epic Game provide us. So we are not going to use that. We will be making a blank project and we will make this as a result. Of course the assets are going to be different, but this is what our project is going to do. So creating blank one, and we are not going to use blueprint. We use C++, maximum quality, console, and we are not going to use starter pack. We have just nothing at all. We will build everything from up, and eventually we will learn how things are done in the real world. So just creating simple FPS and create project. It will take some time. So everything is loaded. Unreal Engine is loaded, and also our project is C++. So Visual Studio is also loaded here. Let me give a basic, quick overview. This is a simple level. This is our viewport where everything is going to go like your character level and everything like this. This is a quick quick shapes and all. You can spawn here for testing purposes. You might not be using them in your real game of course. And this is a browser, and this is a detail and world setting, and this is our all the things which are present in this level right now. Eventually I will be showing you what it does, but let's move on and let me show you. Let's first save our map. So let's create a new folder here like maps, and just naming it our map. Okay, so every time so you have to do one thing also in your project setting. You have in maps and modes, you have to select your our map, otherwise it will every time load a new template and you might lose the progress you have done. So you can do this, and every time when you load the game, this map is going to open. So let me talk to you about how games run in a level. There's game mode which handles all, which is this one which the Unreal Engine provided us. It doesn't have any functionality, just a basic game mode. I can show you in the source simple FPS. You can see simple FPS CPP file and the game mode file. It's an empty file. As you can see, there's nothing in it, so it's waste. We will be creating our own one for that one. And the game mode contains all the functionality, like like they contain the pawn class, which pawn is actually the controller which user uh, possesses in the game, like in Tomb Raider, Lara is a pawn character. So like this. So there are hierarchy in this: actor, character, pawn. I will talk to you about that in a bit. So we have HUD class. You know, her HUD is heads up display, which you know, the screen that shows you all your scores, health bar and all that, which this is HUD. A player controller and everything, you can leave this. You don't need anything of that, like game state and player state. These are mainly for multiplayer games. And spectate class, you know, you played any multiplayer game like battle royale, you will know. To move in this level, you can use WASD keys to move with mouse left or right mouse, anything, and you move inside the level. So basic overview of the engine is this. So let's move ahead. So I am making this plane a little big, so when we start, not going to fall. So let's create a new game mode class. First of all, what is game mode? Our game mode is actually handle what is going to be happening in the level or in the game. You can use this Unreal Engine 4, but let's do that. So you just have to create a new blueprint, and also I need to have, yeah, what is this? Blueprints. Okay, so let's just PP simple FPS game mode. So game mode. Okay, so this is it. So yeah, you can also set this on compile. Always save your game. So like this. Okay, so in the maps and modes classes, there's a thing called default mode. And this game mode you can select your own, like what we create BP game mode, and this is going to handle whenever the game starts. It will handle all what is our pawn is going to be, what's our heads up display is going to be, everything like that. By default it's a default pawn, and we will change that to our own player. Okay, so and there's also one thing, this game instance thing. Game instance is basically, you can say a class where everything is, say, you can say a global class which never picked by a garbage collector. So the variables you set in there is going to be there from the game start to the game end. So you save your all high scores, and mainly the high scores, health, and all these things. In You can save this in a game instance class. You can create your own one, and then the data in this one are always static. So it's not going to be collected by garbage collector, and everything is going to be simple here. So moving ahead, let's create our own create character first. So going in C++, create a new class, and three there are many things here, and if you go and do show all classes, there are way more now. So take it simple. Basically an actor is an object in the game which is not controlled by the player or anyone else. This is just a static object. You can set the static and dynamic also. You can make them dynamic also, but basically a static one which mainly does nothing. As the mainly the actors in the game, you might go like interactable. The actors in the game can be anything like table, chair, caves, gates, trigger boxes, and all this stuff. And act and then comes pawn class. Pawn class is derived from actors, so all the properties actors have it are there in pawn class. And pawn classes has one basic add-on which is a controller, so the player can control this pawn class, move around, and can be like and can move around, and that's it. And further, character class is derived from pawn class, which has all the functionality of a character like jumping, crouching, moving forward, and running, jump, swimming in air, and everything like this. So we are interested in creating a new character. Let's call this main character like this, and I want just further in main character subfolder. So creating this, it will take a bit to compile, and I recommend using an SSD because I know it's really hard to compile, especially Unreal projects on hard disk. I got like 10 minutes of compile time with hard disk, and when I switch to SSD, my compile time is reduced to 50 to 60 seconds. That's it. So I really recommend using a SSD. So let that compile. So it's done compiling. We have this main character class, and this is our character class. Sweet. So we are not going to drop this in this level and start playing. We will create a blueprint out of it, and then that blueprint is going to go in this level. And all the functionality is going to be written in C++. So create a blueprint out of it. Call this pp main cap. Compile this. So in this game mode class, we said for now the game mode is nothing. So we go ahead and uh, set this as a game mode, and for a pawn class we use this character class. So every time, so let me show you. If you don't have this, if you have none right now, this is what it is going to look like. You can do nothing. So go none, then bp main char. You can see this character has nothing in it, so it's not going to do anything. We can't move. We press WASD key. You can see I'm clicking. You can hear I'm clicking. So this is not going to do anything. So sorry. Let's save all quick. My engine crashes a lot. So in this, so basically I have created a simple game gun model to. It's a very simple low poly. To just give you an idea what it's going to be, and also a ball, simple for a level. So I have this basic level, the basic gun model in Blender, and also this contains one bone, simple one bone, just one bone, and this has an animation of shooting, like you can see. That's it. So if when you're exporting from Blender to Unreal Engine 4, the one thing you need to be focus on that, go in this unit scene tab and change, by default it is going to be 1, so change this to 0.01. So this will change everything into centimeters, and Unreal Engine works in centimeters, Blender works in meters. So this will change that, and let's go in export FBX file. With FBX, use this new folder and just create our gun, and uh, use armature, pressing shift armature and mesh, and bake. Yes, click on bake animation in armature and select leaf bone. You can select or unselect only deformed bones. It will not do anything, and just select any face or edge whatever you want. Just export this. So here's a model here. So we create a new folder here and name it details. Let's export, create a folder for gun, and just drag and drop this one. um, Leave this as default and import all. So as you can see, it does not exported the animation, so we will do separately, no problems with that. So you can see basic gun is here. I have no material set to this, so no problem. Physics object, physics asset is there, fine. So save all in Blender and export the animation. uh, so this time no mesh, just armature, only deform bone and bake animation like curl anim. So do this, just exporting this, select this skeleton mesh and just import. So this time the animation should be loaded. Yes, you can see the animation is there. Sweet. So next, in our character class we will do some movement functionalities first, like moving forward, backward, and of course the jump. For this, we need to go to this project setting, and in this you see this one tab called input. So basically all your inputs are going to be go in uh, this one of them, axis mapping and action mapping. The difference is action mapping is basically for inputs like arrow keys and movement functionality and mainly like that, and actions are basically one tap inputs like fire, jump, throw, etc. So we will, for movement we are going to use axis mapping. So go in axis mapping, clear this +1, so name this to forward. We will use mouse to look here and there, and then we will move in the direction of this camera. So we will be using only forward, and inside forward we use W key with value 1, press 1 +1, use S key, search for S, and scale the value to -1. So when our forward value is +1 we go forward, and if it's -1 we go backwards. When you go in this character class you will see there are some things already there. In this report section you see collision capsule and this arrow to show you what is the forward direction. This is going to be hidden in the game, so you don't need to worry about that. And there's a mesh, skeletal mesh, which contains only the meshes which has bone in it. That you can't set this to a static mesh. It's a skeletal mesh. For static mesh you have static mesh. Okay, and also there's one component attached to it which is called character movement, and as you can see there is all this movement functionality predefined here, like your velocity and all. Actually, this jumping, falling, movement, gravity scale, maximum acceleration, all this movement speed and all you can change tweak here is going to be reflected in your game. So in the skeletal mesh, we are going to set this to a gun. It's not facing the right direction, so set we do 90, actually minus 90. So before that, okay, but before that, let's add the camera. New camera component, and it's a pointer, and the name is camera. And of course, don't care about spelling. If it's wrong, that's fine. So we go in this cpp file. In the constructor we go camera is equals to create. Okay, so let me show you one thing. If you are getting this error like no additional information variable, just build your project, the intelligence, and after compiling, if it still doesn't work, I will show you what to do. So it's done, and I also added this hash include for camera component. If you don't know what to include are, just go and google for UE4 C++ and this word like camera component, so it will show you the include file. So when it's done, you can see if it should be showing us intelligence. It see it's not showing, so you go in Unreal Engine 4 and go for refresh Visual Studio project. Just press reload, and after that it should work. Camera is equals to create. Give this a second. As you can see, it's showing now. It's working now. Intelligence is working now. So tap create default sub object of new camera component and see the text. This is the format actually. The format, and like this, we name this camera. So in camera setup attachment and type root component. Basically, root component is a uh, I will show you what it is. This is root component is this capsule. It is defined in the character class which we inherited from. So we don't need to worry about. So when we hit compile now, we build the solution, and after that you will see a camera component is already added to this project. You can see here it's not. After compilation you will see it's added to some objects to be used in blueprint and all that type of permissions. And also this u property thing also helps Unreal to track the objects and do garbage collection and optimize the memory for that. So to do that we use u property, all caps, and it's a hash defined, so you don't need a semicolon. So inside this we use some properties like where you want this to be visible, where you want this camera to be editable, or just read only and read write and all kind of that. So to write this we use blueprint read write.
like this. Okay, and also we use category. You can just say cameras. Category is basically arranging things in hierarchical way, so it has a separate tab which name camera, and all the properties of this camera object is listed there. So now if we compile this, and yes, it's compiled successfully, and we go back and compile this for just for assurance. And I forget something, we need use visible anywhere, uh, delicate visible anywhere, which lets this camera to be visible in the blueprint. And so now we compile, and it's done compiling. And if we go in this, now you can see we can use all the properties of camera. We can even change this mesh, but basically it is hidden in the game, so we don't need to care about that. So now as you can see, so our view is going to be through this camera. We use this camera to move up this like a head, and also we need to add a gun which we created, like let me show you this one, this gun. It's a skeletal mesh, so we can use uh, the skeletal mesh provided in the character class. So we will be using this gun for that. So we go in the E, and in this mesh section we select this gun. So the orientation is not good. Press -90 and change the scale to twice, and as you can see now it's pretty close to the camera now. So as you can see, it is pretty close to the camera. Now if we play the game, the gun is going to be like, yes, as you can see the gun, a part of the gun. I should move this with the far, and as you can see this gun is showing, but we need to move this slightly in the positive of y-axis. Let me show you why. When you hold the gun, it basically in your right side, not the left one, sorry, slightly on the right side of the body. So to give to make things realistic, we move this bar here, and as you can see gun is showing. So now let's work on the inputs to move to see around the world. But before that, let's add a ball. No, let's do the input first. So exit from the play and go in project setting, and in the input, as you can see there are two options. We already did that, okay. So W and AS for movement forward and backward, and also we need to add one more axis mapping for mouse. So in x-axis, use X, we call this mouse X, and for y-axis I will tell you what it is, mouse Y. So basically they are the axis in Cartesian plane, like when your mouse moves in 2D, so it is x and y axis, x axis and y axis. So that's why it is mapping all kind of things. Like if imagine this is a Cartesian plane, then x axis positive is here, minus x is here, plus y is here, minus y is here, and as you can just divide the plus plus here, minus minus here, and like this. After this we can go in C++ file, and as you can see there is a function here which is named setup player input, and this is mainly responsible for creating input methods in your for your character. So it is an overridden virtual function, so we need to add a function which is responsible for certain tasks. like moving forward or backward. So we type void move forward backward. It will take a float value. You can name it anything. That float value is responsible for this one. As you can see, scale value. It when W is pressed, this float value is going to be 1, and when W is pressed, when S is W is pressed, the value is going to be 1, and when S is pressed, the value is going to be -1. So let's just create this function in our CPP file real quick. So after this, we go in this setup player function, and using this U input component, we map this input. So we type player, so it's done. Uh, we go as it's a pointer, we use arrow operator, select axis binding. First of all, write the name which you want to bind this function to. For our purpose, it is forward. So copy this. It should match the spelling, and the next it requires um, and then you like this class, and then the function you want this forward to be assigned to. So we have this move fp. So we pass it by reference. So and operator, a main char, colon colon, and a function name move forward. So whenever w and st is pressed, the forward, the function which is bind to that forward to be called. For our purpose, this is this move fp. I'm sorry, it was actually bind access, not access binding. I'm sorry, bind access, and now yes, it is fine. So we will do all the operation of our movement moving forward and back in this function. So what first check the controller. Controller is defined in this. The controller is defined in this a character file. So we type controller. As you can see, it is already present. We check if it's valid, and if it is valid, we take the rotation of the control. Controller is basically our pawn class, which is currently in control of the player right now. So we find the rotation because we need to move in the forward vector of the player, because in 3D world it's not like in 2D where you move in x. When you press forward, you go in positive x, and you back, you go in negative. In forward, you can be anywhere. So we need to find forward vector of the player and then move in that direction. So we type f rotator is equals like um, rotation, like controller get rotation, get controller rotation. So basically f rotator is just a vector, but their values are uh, not arranged like a vector like xyz. It is basically in pitch, roll, and yaw. And for to show to the pitch is basically when we move in y-axis. So when we move in y-axis, this is called pitch. Okay, and the roll is basically in x-axis, which is this, and the last yaw is in z-axis, like this. As you can see, it's in z-axis. So the constructor of f vector is in pitch, in yaw, and in roll. So basically your x, y, and z is moved to a left. Now it's y, z, and x. Okay, so let me delete this. Okay, so we need to find the yaw. which is the Z rotation, because if you go ahead and see, the main rotation happens, we look up and down but we move in Z axis only, like this. If we only look up and down, we don't move in up like in this way, so we only move in Z axis. So we need to find the yaw rotation of this. So we find F rotator, yaw rotation is equals to F rotator. We create a yaw rotation, rotator, and put 0 0 in pitch and roll, and we put rotation dot yaw. And now we need to find the direction which we need to move the player. So we write F vector, the direction is equals to F rotation matrix, and we put a yaw rotation in this, but get unit axis, and we need to move in x axis. So E axis and then x, actually axis. So it's fine. So to move, add a movement, we write add movement input with, and it takes two parameters. One is direction and the other is value. So we type direction and the value which we get from the function. So if it's -1, it should go in the direction negatively, and if it's a positive value, it will go in positive. So let's build this solution and see what we come up with. It's done compiling, so we should work if we play, I think. So yes, as you can see, it's working. I'm pressing W, it's going forward, and I'm pressing S and it's going in backwards. Fine, let's add mouse input to it. So for the mouse, we already did x-axis and y-axis. So let's create functions for that. Let's type void mouse x. It will take a float val value. And by val, you can put anything, like you want anything. I want to say you can put that, but I prefer val, and similarly for y. Okay, it's done. Let's create define these functions. Okay, done. So let's bind them to our values. So we type layer, put, it is not showing intelligence. It's, I want, okay. So we don't need intelligence. We can just copy this line and paste here, and one more time. So for this one, we need this x-axis value. The function is, okay, sorry, what is happening? We need to do y for this. Done. So these functions will be called when a mouse x and y axis are called. Okay, so to move up, to look up and down, we use mouse x, mouse y value, y axis of mouse. So we need to set some parameters, because if we don't, then it will do the 360 degree. So we can look -20 in downward and forward maybe 50. So we will clamp the value to minus. So we will do that for -20, and let's say we can 80 is fine. -20 and 80. So we go ahead and first, and to do this we just change the rotation of the camera. So we create a new rotator, new r is equals to camera get relative rotation. But so we go ahead and create new r dot pitch is equal to fmath clamp the value, and the value is going to be new r dot pitch. So basically clamp works like that. It takes three parameter. First one is our value, and second is our minimum we want to set, and the next is maximum. So when it goes more than maximum, it will clamp that to our respective maximum values. So I will teach you what that, I will tell you what that does that mean. And for -50 and 80, if the rotation goes 90, then it will clamp back this back to 80. And if it goes below -20, like -30, then it will clamp it up to -20. So so as you can see, it is showing error. It's basically showing error because this f clamp value, f pitch value is float, and these two are integer value. As you can see, integer, so float integer. So let's build the solution. So it builds, let's and play. It's not working. Oh, the final thing, we didn't add this rotation to our final value. So we go in camera dot add dot set relative rotation and accept the f rotator which we have marked. So let's build.
It's working. It's working now. I'm moving my mouse down and it is going here. We look up. We'll move my mouse up. It is looking up. Yes, we can just see up and down. So here's the problem here. You can see the gun is not following our camera. So what is the best way of doing this is making that gun skeletal mesh child of that camera. But the thing is, this mesh is set to a child of capsule component in this a character class. So what we will do is create a new skeletal mesh and make it child of view camera component. So let's close this. We go in here and we will use the this delegate and make class, because we are not defining this in header file. We will define this in CPP file. So you skeletal mesh component pointer inside the gun. Okay, so we go in cpp file, and the cpp file and the hash include for this is this calculate component. So make sure you are writing this spelling here. Just add a u before that. So fine, we go here, we go gun is equals to create, and just copy, and in here we write skeletal mesh, use skeletal mesh, and the name of that is going to be like gun. Okay, so we go gun, setup, attachment. It's not going to be root component, it's going to be camera. Okay, so now we build the solution. So until it's compiling, let's also have this ball so that we will throw. So let's add that. So I'm calling this 001, import that, and it's just a sphere with no material at all. Okay, just a sphere. So it's done compiling. It took a while because we did changes in header file, and takes more time when we do changes in header file. So we go in this pp main cap. As you can see, there's a skeletal mesh gun here. So what we will do is just clear out this one, we don't need that, and you can do this, but it doesn't matter. We'll go in gun, choose this mesh, and the scale is 2 minus 90, and let's place this. That is fine now. So it's compiled. So let's see the result. So gun is missing. It is out. Okay, sorry. Let's move this further, and yes, as you can see now, the player is controlling the gun. So let's do the movement in the z-axis. So basically when we move, we don't need a constraint clamp the value, we can do 360-degree movement. So what we will do is just add that value. So yeah, so create f rotator, rot is equals to camera dot get relative rotation. Okay, so we do camera dot set relative rotation to rot. So in here we will do rot dot r plus is equals to l. So that this should work. So it's done compiling. So it's compiling. So it's done compiling. So let's see. So yes, we can, as you can see, I'm moving the mouse, and it is working. We can press this WASD key and it will work, but as you can see I'm only moving in one direction. In the movement section we need to have the forward vector of the camera. The camera, sorry, so we like camera get relative rotation. So let's build. So let's see if it works. Now as you can see we are moving in the direction of, we are moving the camera. So we W and we can move in any direction. So as you can see, but the missing part here is just the firing part. When I click the mouse button, there's nothing happening. As you can see, I'm clicking mouse and firing. So we need to build that. So for just I am creating a new blueprint which will contain nothing but an actor. As I've told you, actors. So we name this bullet. Actors are some basically static objects mainly. We can add sculpture mesh and animation like that, but it will not affect the world as much. Our player does. So we create a static mesh. Don't need to change anything. Sculpture mesh and just you can choose the ball we created. Okay, it's big. We choose 0.5 maybe 5.5. Let's see what we come up with. So we need to fire from uh, here or here from the muzzle of the gun. So what we will do is we will add a new box collider, box basically, not collider, for, and from that location ball is going to spawn in the world. So let's create that box component. So we go in, so we can copy this part and the name is u box component. Call this just box. So, and we can just do this real quick, box and we want this to be child of camera, so we can leave this there and we just in this box. Okay, and we need to change this to u box component. It will not compile, we need to add the hash input for that, and that is this. Sorry, so it is not recognizing. Okay, so it's done. So let's compile this. We can set the position of the box in C++ also, but for our sake, for simplicity, we will do this in blueprint. Okay, so it's done compiling. So let's see. So let's, yeah, as you can see we have a box here and we move this. We can reduce the size of it. Oh, but don't do here. We can change the size from here also with 20 20 20. It's a big 5, but the size doesn't matter. So we move this here. Remember, this is the position where a ball is going to spawn. So arrange this very precisely. I think it's fine. So for this bullet blueprint to be added in a game, I'm not creating spawning the static mesh. I'm creating through a blueprint, because whenever you need to change the ball, you just change here, just add a new static mesh, add particle system and all this, and it will not affect this file. So it's a good practice to work in modularity. So we are doing that too. So to add this blueprint, what we are going is basically an A actor. So what I'm doing is I'm creating a, so to add this we are doing T sub class of, it is basically an A actor. Yes, this one. So we're calling this, you can call this ball, and you can create this as U property, but it doesn't matter, but it is a good practice to do so. Just leaving this here. So when shooting is happen, we will create a function for this, but this time what we will do is we will not create an action axis mapping, we will create an action mapping. So player input component find action, and the action is going to be, we will name him flyer, and it is require a input event, and event is basically pressed or pressed up, pressed down, like this. So we write IE pressed. Okay, and simple, we will do similar to the axis mapping this and the function name. Okay, main char is going to be a fire. Okay, so let's quickly create that function. And the action functions does not contain any values, they are called once, so it doesn't require the value. So let's define this function, void a main, as a main cap fire. So here the ball is going to be spawned from the player. So what we will do is spawn this here. So let's create, first of all, include, we don't need to include anything. So what we'll do is, first of all, check for the world. If get world is, check for the world, if it is good, then spawn the actor. So we write a actor because it's going to return a value. So let's call this ball and is equals to get world spawn actor. In the square bracket we initialize what we want. So we need an actor, we are not specifying it, we making as a parent class. So everything derived from a actor can be spawned here. We can even spawn a character because it is derived from a actor. So what we need is here is, so before spawning we need spawn parameters. We add this a spawn parameter spawn, and the owner is this. So we add what actor we want to spawn, and this is our ball. So we spawn ball here, and here we initialize the location. The location is going to be the box. So box get world location. Actually in CPP it's get component location, and the rotation we want F rotator is 0, and the spawn parameter is going to be spawn para. So So it will work now, but before that we also need to check if ball is valid or not. If we don't set this in blueprint, then it will not spawn anything. And if you don't do this check and run anyways, and you don't set anything on blueprint, the engine will crash immediately. So after that, after this, the ball is just going to spawn and drop on the floor. We need force to move this forward. So we will do this after I show you how it's going to spawn. So let that compile it. Yes, it's done. I don't know if it is done here. So let's check. It's not. Oh, sorry. I didn't set that in blueprint. So in blueprint, if we go in this area, we will see some. Of course, you see, I okay. So the delegate that we that the subclasses will use is edit anywhere. Edit anywhere. So now we can edit this object anywhere. So it's done. So now as you can see, we can select an egg actor from this. So we will select the bullet. You can see we have fucking bullets. So when it's done, as it's not going to happen. You know why? Because didn't set the input. You go in input, we create an action mapping. We're to name this fire. Pick a fire. It's capital X, I guess. Capital F, no small f. Fire. Mouse left mouse button. Now we go and just you can see it is spawning. Very nice. We can play. Nice. So the size of the ball is very big. So what we will do is put the size to 0.2, 0.2, 0.2. I think, and in bullet it is not simulating physics. So we will set this to simulate physics and done. So let's add this. So we hit that. Yeah, as you can see, it's working fine. So it's spawning right. So there's a change in the plan. So let's do this fire function in the blueprint also. So you will learn about the blueprint also in this tutorial. So we remove this. As you can see, you can spawn very quickly with this, but let's do fire function in blueprint. So let that build the function. So we can go in event function, and there is an event called fire, which is our input. This is an input. As you can see, it's an uh, action action mapping fire. So as you can we will do this again. So we type fire and we do spawn actor from class, and this class is going to be of course bullet, and spawn transformation. We need to set them like make transformation. we need the location of box world rotation location. Need to add this, so it will return an actor class. Okay, so we type add impulse to that static mesh. So the impulse is going to be direction multiplied by the value. So we will do get the camera, get the forward vector, just multiply this with a random value, let's see 500, and impulse, make sure change the velocity change. So when we now run, okay, now you can see little impulse, but our change to the size was not saved here, so let's, it is actually saved. Okay, it's not changing the value, so we can change this here also. We use static mesh and set world scale, and we can change this to 0.1, 0.1, 0.1. We need to change the value, so move this to 5000. Now, okay, too small now. We change this to 0.5, 0.5, 0.5. So now as you can see, it's working fine. So to give you an idea, let's create a simple level. They all should, I think they might, yes, nope, they are not simulating physics. I don't know why. Let's change this to, let's simulate physics. Let's change the size of them. But fine. So let's create control W, control W, control W, control W, control W, control W. Okay. Now as you can see, it's working fine. You can destroy this with overlapping, but we are not doing this here. We can do this. As you can see, it's working fine. This, and you can add the sound and effects function. And oh, okay, so one thing is missing, the animation. Okay, so when we shoot, we want this animation to be played. So what we will do is uh, take our mesh and just play animation, and we need to add animation here. So the animation is this gun anim. So let's see what we will have now. See, now it's okay. So this is a simple FPS game. You can do whatever changes and make the next effects or anything you want. So I think that's it for this video. I hope you enjoyed this, and you can subscribe for more videos. I hope you enjoyed this. Subscribe for more like this video, and see you guys in the next one.